So hello everyone. So today, good morning, and today I will introduce the result of my final year project in the second semester. It is about the safe data transmission protocol, and my supervisor is Professor Can Kun-ki. Professor. Now I will start my presentation about my final year project. Before my presentation, I will give some follow-up of my first year for the final year project I have done in the first semester. It is about Android dynamic loading, and this semester I have read two books about this Android dynamic loading. It is about one is the source code analysis of Android smartphone, and the second is about the Java virtual machine. So, considering that, I have come up with two new ways of develop the Android's dynamic loading mechanism. The mechanism itself is remain unchanged, but there are some more advanced programming skills can largely improve the efficiency of that mechanism. So this is the follow-up of my first final year project, and now let's continue to my second semester final year project. It is about the safe data transmission protocol. In this semester, I have developed an app. So this app will be demonstrated just at time, and this app can capture the signature using Android Canvas, and the signature will then be safely uploaded to the server using my own protocol. This protocol is a SSL-like protocol. There will be a handshake phase, key generation phase, but there will be some differences between SSL and my protocol, because my protocol is operated on the application layer. So let's start the introduction. So let's start about the introduction. The uploading mechanism contains three phases. The first phase is client hello phase. In this phase, some initial parameters are exchanged, and for example, the digest algorithm that's used in the next two phases will be negotiated in this phase. And in the second phase, client side and server side will authenticate each other, and they will exchange another part of some parameters. And the second phase, the parameters that exchanged in the first and the second phase will be fed into a predefined mechanism, and this algorithm will generate the session key that will be used to upload the data on both sides, because the input is the same and the algorithm is the same. So RSA, MD5, and AES algorithm will be used in this mechanism. And if the image is too big, we can also apply compression algorithm using gzip, and to avoid some coding scheme confliction. For example, the GB1321 or Big 5, we all use UTF-8 encoding method and use base 60 code encoding to encode the encrypted data. So this semester I have write two server-side programs. The first one is Java using servlet, and this servlet will be migrated to SSH framework later. And also the other one is more lightweighted. It is Python bottle on Cherry PY. So currently, the most popular way of Android app to upload an image is via HTTPS. Android app just show you a web view, and the data will be encapsulated in an HTTP request and sent to the server and further processed by the web server. Also, some apps will also use sound log, for example WeChat or Fingerprint, iOS or Samsung smartphone, and also some other apps will also use SSL directly to safely upload some data. But there will be some problem or issues in this mechanism. For example, fingerprint and sound log can be forged. So for example, if bad guys want to forge your fingerprint, they just need to scan your fingerprint, and they can produce some material to pass the fingerprint test. Also, if you encapsulate your request in HTTP request, then this will be impose some workload, for some high workload on the web server, and there are also two other issues. And also for if you use SSL directly, if you want to authenticate both client side and server side, you must add a LDAP server, and you must have to generate the certificate in the client side. This is very costly. So considering that, we may conclude that a more lightweighted safe transmission protocol is needed. Now I will give my solution. So, if a bad guy wants to hack into this algorithm, he must know the full password. But for a normal user, he just needs to remember 2 of them. The first password is the login password. This password is seldom used. It only used in the first login, and will use if you change your smartphone. And also, this is the most unsafe one because this is very vulnerable to dictionary attack. And also the second password is safer, and this second password is only stored in the client side and never uploaded to the server side. Server side does not even know about this second password, and this second password, the ideal implementation is via fingerprint or sound lock API. So, and the third one is vcode. Vcode is an 8-digit number. It's generated on the server side and stored in the database, and it will be sent back to the user via SMS. Notice that this vcode will never be stored in the smartphone client side. We assume that the user will just remember the vcode and delete the short message immediately in order not to be obtained by the bad guy. And also the session key. In fact, the client does not even know about the session key, because session key is different in each upload. And this session key will generated by the server side and client side independently. So the client does not even to know about this session key, but bad guys need. Okay, so just mentioned before, my algorithm contains 3 phases, but there also a phase 0 that in the registration phase. In this phase 0, the user must set the login password and the second password in the client side, and in this phase, the MAC address will be sent to the server, and the client will get vcode via short message. Okay, so now let's proceed to the first phase. In phase 1, this is the hello phase. Client side will send a message containing 3 parts. The first part is a UID. So what is UID? UID is the short for universally unique identification. And by theory, a smartphone can generate 1 billion UIDs in 1 second. And this UID is computed using some digest algorithm, random number, IEEE MAC address, and the time, the exact timestamp. So this UID will be guaranteed to be unique, and then 8-digit random number. So this number is just a random number generated by the program, and the English word. So this English word refers to the exact hashing algorithm that will be applied in the next 2 phases. Here we use MD5, but we can also choose SHA-1. Okay, so the server side, after receiving the first client side hello message, and also the client side message will be encrypted using the public key. This public key will be downloaded in the registration phase. In fact, it is embedded in the app, so there will be no vulnerable. It is not vulnerable to man-in-the-middle attack. Okay, so after receiving this message, the server side will have two choices. The first choice is it will send back a certificate for user to use Java API to authorize it. And the second phase, this phase I used in my app, it is the hash string of UID and the random number +1. But this can be a totally different function, but this function should be a one-to-one mapping. Okay, so this is the first part of the message. This is the MD5 digest, and also there will be another random number. This random number is generated by the server, and it acts as a nonce. Okay, so this nonce will be used to protect the app from replay attack. Okay, let's proceed to the phase 2, that is the authentication phase. After receiving the response from the server, the client first will so the test if the received MD5 message is correct. If correct, then it will use the second password to authorize if the user that currently using this smartphone is the user himself, because this is the fingerprint or sound lock. Okay, so this second password authorization will be not known by the server side, and if the client side passed the second password, and the client will be then required to input the V code, and note that this V code will be destroyed immediately after this message has been sent out. Okay, so the next message sent by the client contains 4 parts. The first part is another UID, the second part is the V code, and the third part is the MAC address, and the last part is the sum of the 2 integers. Okay, so this message will also encrypted using the public key embedded in the app. Okay, so after receiving this message, the server side will check that if this sum is correct, and then it will query the database to see whether this V code and this MAC address is consistent. If consistent, then the client side will return a JSON format OK message to notify the client that he can proceed. The both side is ready to proceed to the uploading phase. And the phase 3 is the key generation phase. Notice that the UID-A, UID-B, V code, and MAC address is consistent in both sides. So now both the client side and server side will generate their key independently using MD5 hash algorithm. Okay, so the session key will be so this here is not the first, but the whole 128 bit of the hashed result. So this will be the session key, and then will be fed into the AES algorithm, and now our file will be encrypted using AES and uploaded to the server. Okay, so now let's proceed to the next part. It is the attacking method and their corresponding defenses. The first is replay attack. Well, this can be defensed using this nonce and this nonce. Okay, so DDoS attack, the server and the client will reject all subsequent requests if they detect there will be 3 times failure. So if there will be 3 times failure, then the uploading module will be deactivated, and it can be later activated using the full password. Okay, so another man-in-the-middle attack and physical link hijacking. This is naturally defensed because our private private key, our public key is distributed, just embedded in, is distributed via the app, and there will be no chance for the middleman to inject his public key or private key. Okay, so I think the most practical is your smartphone is stolen or your smartphone is lost, but even if this happens, the bad guy also need to know to pass the second password, and he also need to know the V code, because since V code is not stored in the smartphone, I think this will be much safer. Okay, then choose plain text attack. This will not work for my protocol, because in the first phase there will be no critical information sent out. So okay, so dictionary attack also dictionary attack also is protected, because the V code is generated randomly by the server and not by the client using a meaningful password. Okay, so there will be a lot more in the Wikipedia, and I have read that list, and I'm sure that my protocol can defend each of them. And okay, so about assessment on future application, so this mechanism or this protocol can be used in a credit card application, and for example, the signature that captured in and uploaded to the server will be fed into a machine learning algorithm to detect whether this signature is really written by the client himself. Also, because the computation power of the smartphone is increasing day by day, so in the near future, the 128 bits long, so where is that? Okay, 128 bits long key maybe not enough, and then we can proceed to 256 80-bit 50-bit. So to make our protocol more safer. Okay, so this is the presentation of my final year project. Thank you. Okay, so the demonstration start. Okay, first let me get my signature here. Okay, so click get my signature. Oh, sorry. Okay, so now you can just draw in the canvas. For example, I will write my name here. Okay, so I will give my name, for example, because there will be some issues on my touch screen, so I just name my name as PPP. Okay, so if I click save, and the server side will receive the server side will receive a screen that contains by UIDA and the random number and the MD5 digest, and it will generate the digest and send back to the user. And here, because my smartphone does not support fingerprint or sound lock, so I just give a text here to indicate that I have passed the second password. Okay, so the next part, I will be asked to input the V code, and we also notice that when I pass the second phase, there will be no request initiated from the user to the client, because the second password is a locally method to authorization. So my pre-configured the V code is POIUTY. Because there will be some issues in my number key, so I use char array instead of numbers. Okay, then I click next. Okay, so we can see that. So we can see that the RSA decrypt method is here. The MAC address, the V code, the user UID1 and UID2 are also configured, exchanged between each other. And there will be a toast here to show that the client side has received and authorized the user side. Okay, so this is the decrypted image, and not here. I will show you the uploaded image. Okay, so I think this is the same as that one, right? So here is the end of the demonstration. Thank you.